Hello everyone. So let us look into the ionic bonding. So ionic bonding by definition means here we have the involvement of loss or gain of valence electron. So one atom loses the valence electron, another atom gains the valence electron. Or it can be said to be a transfer of electron from one atom to the another. So let us look into a very common example, that is your common salt, which is nothing but NaCl. So this is your sodium atom and this is your chloride atom. So I've written the corresponding electronic configuration, and the third shell represents the valence shell of the sodium atom. Again, the third shell represents the valence shell of the chloride atom. Now, the sodium atom, if it loses one electron, it will acquire a noble gas configuration, which is nothing but 1s2, 2s2, 2p6. It's a completely filled orbit. So in order to achieve this noble gas configuration, it has to lose this electron in its valence shell. So when it loses the electron, and as a result, what happens? There is a positive charge that comes into the picture. It's not that the positive charge is created here. What is happening is here we know that in the nucleus you have the protons, and and there is equal number of protons and equal number of electrons. So when one of the electron is lost, there is a misbalance. So more of positive charges, one positive charge extra is there on the nucleus, which is not neutralized, and therefore we say that sodium is one positive charged. Okay, and similarly in the chloride ion, what happens is that if it gains one electron, it achieves a 3p6 configuration, which is a filled configuration. And so that is why it easily accepts an electron to form the corresponding chloride ion. Here again, here what is happening? There is an extra electron coming. That misbalance is because of an extra added electron, and that's why it gains a negative charge. Okay, so this one of the atom loses, another atom gains. As a result, oppositely charged ions are formed, and the electrostatic attraction between these ions is what leads to the formation of the sodium chloride compound. Okay, and this electrostatic force that holds this particular ions in this solid state is what is referred to as your ionic bond. Now here, if you look in here, you will find that, let me go back. So here I have written down a definition. If you look here, it is written, number of electrons lost or gained represent the valency or electrovalency. Not, please correct this. It is not let me correct that for you. It is not valence electron, but rather it is the electrovalency. Electrovalency. Okay, so please correct this particular thing here. So the number of electrons that is lost by the sodium represent its valency. So here the valency would be 1. And the number of electron gained by this chloride ion represent the corresponding valency of the chlorine atom. And that is nothing but 1 again. Okay, so number of electron lost or gained, okay, represent the valency or the electrovalency of that particular atom. Please keep this in mind. Okay, so let us move ahead and try to understand these ionic compound in more detail. So this is a kind of more layman definition and a layman understanding about the ionic compound. Now we have to understand in more detail and more conceptual way, what do you mean by a ionic compound and why they are formed? Okay, always we have to keep in mind that being in a science field, a why answer should be answered. So everything that you study, keep in mind that you have to find out why that is happening. There is not, because science is always factual, okay, and everything usually comes from a reason. So whenever you study, try to understand that reason. Once you are thorough with those reasons, it would be better appreciated, and you will remember all these things that you are learning. So let us look into the ionic compound. So when we look into, let me move ahead. Here it comes. So here I have given you, again taken the example of NaCl to explain to you in more detail the formation that is happening in this particular compound. Now, to form NaCl from its constituent elements, so NaCl is formed. Now here I am trying to represent the states of the states in which they exist. Okay, so sodium exists in solid state, so I have written down sodium as solid, combining with chlorine, which exists in the natural state as a gas. Okay, and they combine to form sodium chloride, which is uh, the ionic compound. Now, when we look at the delta H, or the enthalpy, which you might have studied, it is a negative quantity, which is minus 381.8 kilojoule per mole. Now, because this value is a negative energy, there is a decrease in energy in the system. Therefore, you have the formation of this particular compound feasible. Suppose these constituent elements, when they combine and you get a positive enthalpy value, then the formation is highly disfavored, not favored at all. So that is what I have written down here. A decrease in enthalpy favors formation of ionic compound. So we just now understood when the sodium chloride is forming from its constituent elements, it leads to a decrease in the energy or the enthalpy, and as a result, the formation of this sodium chloride or common salt is highly feasible, okay, or favorable. Okay. Now, what are all the factors actually responsible for this negative value? That means, because if you see here, you are going from a sodium to a sodium positive state, okay, and chloride to a chloride negative state. So it involves some processes, okay. So a combination of the values of individual process is what is giving you the ultimate negative value of this particular enthalpy. Okay, so let us look into each step that is involved, where there you can see some changes happening in the constituent elements, ultimately combining to give you the ionic product. So let us look into each step individually. So what is happening to sodium? So sodium exists in its natural state as solid. So initially we have to uh, convert it into sodium gaseous state. Okay, so basically solid to gas is what is happening here. So we know that when a solid is converted directly into its gaseous state, we call that process as nothing but the enthalpy of sublimation. So that process is called sublimation. Okay, so here the enthalpy that is involved here, basically, let me write that for you. Here, the enthalpy change that is happening is basically the enthalpy of sublimation. So solid to gas. So we know that to convert a solid to gaseous state, we require energy, and therefore this is a endothermic process. Fine. Now, the next step. Next step is conversion of this sodium gaseous into a sodium uh, positive gaseous. So that means here you have what is called as ionization energy happening. Ionization energy happening. So that means you require an energy to remove the valence electron from the elemental sodium to form a sodium positive. So that requires energy, and that's why it's an endothermic process. Okay. Now let us look in. So we have reached to the ultimate aim, that is sodium positive gaseous. Now let us look at what are all the changes that are happening in the chlorine. So chlorine exists in the gaseous state. In the natural elemental state, it exists as Cl2. So we have to first convert it into its atomic form. So that means you have to dissociate this diatomic chlorine. Okay, so here we have the enthalpy of dissociation that is happening here. So we dissociate this Cl-Cl bond to get the chlorine atom. So that is again a endothermic process. We are requiring the energy to form the chlorine gas. Now, next step is you make the chlorine to accept an electron. So it's chlorine easily accepts the electron, okay, and therefore this process is called the electron affinity. So this value is highly negative, which is minus 348.3. So what you see here is to go from sodium to sodium positive, it is all endothermic process. Now from coming to chlorine in its gaseous state to chlorine negative in its gaseous state, it is having one negative value of the energy. Okay. Now, if you remember the Hess's law, if you remember the Hess's law, you know that Hess's law states that if you want to know the enthalpy of a particular process, it is equal to the addition of the individual steps that are involved in the alternate path. So you can reach to sodium chloride via combination of sodium solid plus Cl2 gaseous to form this particular uh, ionic compound, or you can reach sodium chloride by these steps, that is first converting into a gaseous state, then sodium gaseous, similarly all these individual steps to ultimately give you the solid compound. So taking into account that Hess's law here, okay, taking into account that Hess's law here, what you find is that this delta H, this particular delta H value can be written as a summation of all these factors: delta H sublimation, uh, the ionization energy, delta H dissociation, and then electron affinity. And then ultimately this last step, which I am representing as delta U, okay, which I'll be explaining what it is. So ultimately, according to Hess's law, we can write delta H to be an addition of all these things, because this is an alternate route to reach the sodium chloride. Now, when I do this, what I find is that when I put these values here, so here, since it's half of the chlorine, so that's why I have to divide it by 2, then minus 348 plus delta U. So when I put all these value and calculate it, I get it to be 376.9 kilojoule per mole plus delta U. Okay. Now, as you can see, this delta H value is highly negative. But to get this highly negative value, you require this particular value to be highly negative. That means delta U should be highly negative. Only then you can get this highly negative value for the delta H. So that means this particular value plays a very important role in the formation of the ionic compounds. Okay, so that is what I wanted you to say to you by this particular explanation, that delta U is the major factor that is actually contributing towards the formation of this particular ionic compound. Okay, so that is what we have to understand. So what is delta U? Delta U is nothing but called as the lattice energy. Okay, delta U is nothing but called as the lattice energy. Now, if you are asked to define what is lattice energy, it is nothing but the energy released, okay, because it's a negative value. So energy released when 1 mole of an ionic compound is formed from its constituent gaseous ionic ions. Okay, so gaseous ionic ions, when they combine to give you 1 mole of an ionic compound, the energy released in the process is referred to as the lattice energy. Now, lattice energy is the thing that is actually the contributing factor towards the formation of a ionic compound. Okay, now what is lattice energy and how it is determined is what we are going to study in the next video. Thank you very much for your attention.